Try quadratic formula. One technique. Tell me another. I don't think it's going to work here, but we can always attempt it. Factoring. And the next one could be, well, this could maybe that I have not done myself, but does anyone know another method that you could apply here besides quadratic formula, besides trying to factor it, to get those two answers, two zeros they call them, for a quadratic? What else could you do? I could graph it, okay, which we have not done much graphing of the parabolas yet. We will in chapter 2. I could look at a graph of it. And now number 4, what I really want to focus on is another technique. It's called completion of the square. Which I've mentioned, but have not done much with. Completion of the square. Now, you tell me though, as a good solid student, if you're presented with this quadratic function, and they ask you to find the real zeros, stay away from imaginary numbers, what would you do? If it's just open and it's open to you as a student, you may try anything you wish. What would you do the way this one looks to find the zeros? Yes?
Isolate the x's.
Can we get it now?
Isolate the x.
In fact, I think, no, hang on, look at this. Is it right now given to you in this form?
Yeah.
I don't have to move anything. I know what you're thinking. You're thinking about the completion. I'm not there yet. I'm going to say now, if it's right now open, based on what we've done in class, what would you suggest you do? And it's open. I do not insist on which method. And you say, I got to find those two answers. I got to find those two answers. How would you find those two answers?
I would probably plug it into b squared minus 4ac, and if it doesn't give me a perfect square.
Okay, first, and our student was asking about that. A student saying, Professor, how would I know? So on Monday, when you give me equations to solve, a quadratic, how would I know not to sit there too long and try to factor when actually you gave me one that will not factor? Yeah, you can quickly check this right here. This little check. That little piece there that's underneath the square root in the quadratic formula. Make my replacements. That's 6 squared. Subtract 4 times 1 times 3. Guys, if my math is correct, that's 6 subtract 12. That's a negative 6. Is that all correctly? B squared minus 4ac?
It's 6 squared, no, it's 36.
36. 36 subtract what? 12? What is that, 24?
Yeah.
Now, okay, we got 36 subtract 12, 24. What does that tell me?
You can't factor it.
I can't factor it. Why can you not factor it? What are you hoping to get for a little check before you start the problem? What would that come out to be if it could be factored? A nice perfect square, like 25, or 36, or 49. So if you want to do that before you can start your work, because some students will sit there and take maybe 2 or 3 minutes trying to factor, and the thing will not factor. And you say, oh my goodness, I tried all this and it won't factor. Then you go back to the quadratic formula. Well, you could do this little test real quickly right here. And if you do not get a nice perfect square here, don't try to factor. This thing will not factor to begin with. Don't waste your time. So this is out. So what do I have to turn to based on what we've done in class? Quadratic formula. So if I go to quadratic formula, I'm on the side here. X is equal to, here we go, negative b, where am I? Yeah, negative 6 plus minus square root 6 squared. Subtract 4 times, just like we said earlier, 4 times 1 times 3, all over 2. And if I do this correctly, this is negative 6 plus minus. Guys, did we say that was what, 24 earlier? I think we did. All over 2. Now I can finish it up, except I still have that 24. It's not perfect. Can someone come up with a nice representation for square root of 24?
2 root 6.
2 radical 6. All over 2. Now can I go further?
Negative 3 plus or minus.
3 plus or minus 1, or just radical 6. And look at that. You're done. Those are the answers. Finished. Okay? So nobody's gonna go wrong in that. So if I say use quadratic formula on the test on Monday, if you use quadratic formula, nobody's gonna miss that on the test. Now though, I put in red. Let me ask you this. I gotta be careful myself as I look at this in preparation for this. Please tell me. Yeah, here we go. Would, I'm gonna rewrite the function up here as this. Beautiful. Please tell me, is the black that I just finished up, the black function and the red function the same? But they're written differently. Are they actually the same?
Yes.
Okay, let's expand the red out. If I expand the red out for a check, this becomes right quickly x squared plus what? 6x plus what? 9. And then I gotta subtract 6 on the end. Please tell me, put all that together, put my numbers 9, subtract 6. Does this red take me right back into the black? Is that true? Is the red equivalent to the black? Now, would it have been easier if I had recognized that early on and now say solve it and use the red version, this version, and set that equals 0, and not use quadratic formula, and solve it from there. Now, how would you solve that if it looked like that? Someone give me an idea. Without quadratic formula, now what would you suggest I do?
Add 6 to those.
Add 6. Move that 6 over, then do what?
Square root.
Take a square root. And of course, the left-hand side is nice, and you expect 2 answers, that's why you put plus minus. And there's that radical 6, which I can't do anything with. And then do what to solve for the x? Move the 3 over, subtract 3. Now, please tell me, with this little demonstration, does that lead me right into what we had earlier?
Yeah.
Except I did it by quadratic formula. Now I did it by looking at a square. Which one do you think would be easier for you? Now, I love quadratic formula. And if I say use quadratic formula, you gotta use it on the test. But if I say if it's just open and you're clever, would have been a little bit faster if you can recognize that this is true. Would this method up here been a little bit faster to get to the answer? Yeah, because I think on this one we had a square root of whatever it was. What, 24 we had to worry about? Break down 24. And the other method, no, it just worked out nicely. Now, Professor, can all quadratics be placed in a form like that? They can. Now, how on earth am I going to go from this, here's the black, and change it into the red, which was up here, right up, to go from the black to the red, and that's called completion of the square. And there's a process. There's no square being done down here. I see X square, but it's not like this. So they're saying complete the square and make it the black turn into the red, and then maybe solve it. With me, guys? It's called completion of the square. Now, with that said, though, let's see what's going to happen here. We move into part B. And I had something really nice here. Let's see what it I had. Here it is. Why not? Here goes. I'm going to jump right into it for this class. I have another function, h of x, and it's given to me as this. Oh boy. Okay. I'm jumping fast. Let's see what's going to happen. Now, please tell me if it's open. Now say solve one of these, or find the zeros, find the real zeros. In other words, solve it. And that's all I say, find the zeros. Just say, thank you, Professor, because I'm gonna try one of these techniques to do it. I think actually this one will factor, I think. So many students would jump in and say, Professor, I'm gonna do it like this. The factoring technique, 2x, x. Oh yeah, -5 there, I do it quickly, +1 there, step back and look at it, looks good. Split this up, it's called zero product property, which allows me to do this. Set each factor equals 0, no problem. You're going to end up with 5 halves, no problem. -1, no problem, if I have no mistake. And I'm gonna place mine in a set. And it'd be done. Is that true? So that right there is one that factoring would be the best. Now, you may say my factoring skills, Professor, are weak. But if I say do it by factoring, it's gonna be done like this. If I say just solve, or find the zeros, it's up to you. By the way, you guys who would like to use this quadratic formula again, on this one, you'll get the same answers. Now, you say, Professor, can you do this method down here? On that, you can. That's where I'm going. It may be a little bit tougher on this one to complete the square. Now, to gradually move into it, can anyone tell me, I did a completion of the square on that last one. Can anyone tell me, if I want to complete the square, rewrite it in other words, I like to rewrite, if I can, h of x in another form, like I did this one. And then solve it by taking the square root of each side. What might mess me up on this one? The way it looks. It can be done, just pretty tedious. What might be messing me up? The coefficient is a 2 here. If that leading coefficient is not a 1, you're gonna have issues. In other words, you can't do completion of the square. Thank goodness back here, guys, I had a leading coefficient of what? 1. It worked out beautifully. Here, coefficient of 2 will not. So I'm gonna redo this problem. Now watch carefully. By completion of the square, I'm supposed to get the same answers. So on the side here, now let's do this. Let me put it right here. I'm doing this. And I don't want to lose anyone on this. I want to complete the square. Guys, my function is this. That's my function. Oh boy. I like to change it like I did here into the red. And one of my students saying, Professor, the leading coefficient's gonna mess you up. Can I make that leading coefficient a 1? Can I do something there in that function to make it a 1? It's not a 1 right now. What can I do?
Move everything over.
I don't have another side right now. Divide by 2, or take out 2, factor out 2. Okay, so let's factor out 2, I'll do it in red. Watch carefully. And I know I have a fraction there. It looks like maybe, I'm gonna do this, guys. I got the x's here. And then I got the -5. I'm concerned with those x's. Let's not mess this up. I got the 2 there on the x's. I'm really concerned with the x's, because we'll complete the square of the x's. Now, back here, I think, guys, back here on the one I just did, if you had done the same thing back there, group the x's, what would it have really taken to make what happened here happen? What would I have to really do? Let me go back to the first one there. I had x squared plus 6x, we've already done it, plus 3. If I want to do it by completion of the square, a group like that, please tell me what would it take that I must, and then use the word complete, add. What must I add to that to make that come out, which I want?
9.
A 9. Now, where on earth would you get that 9 if you don't see it quickly? There's a little process. Some textbooks will show you. Yes?
You take half, the middle numbers
half of that previous coefficient and square it. Half of 6 is 3, squared is 9. Now, as you look at it back on the original here, guys, I got x squared plus 6x plus 9, but the original was x squared plus 6x plus what? 3. So what I want to go back to the original, but it's just written differently. What would I have to do? Put minus 6 here? Now, is all this the original back here? Is that x squared plus 6x plus 3 now?
Yes.
Isn't that cute? And then this factors into this. And eventually we got something like that up here when I solved it. Now set this equals 0, move the 6 over, take the square root. That's where they came from. That's where they came from. You take half of that coefficient squared, you got to put it in there, but then you got to play around and make sure, the trick is, to make sure that all this, when you finish, is the original function. X squared plus 6x plus 3, which it is. But it's written a little differently. So I get that square in there. That's why they call it complete the square. They want a square in there. Yes?
So just to clarify, you added the 9 into the parentheses, and then outside of the parentheses, you subtracted the 9?
And there you go. There you go. Look at this. Look at this. She said, Professor, could I do this? You put a plus 9. Could you quickly put a minus 9 there? Right? And then I think the original had a what? A plus 3 on the side there somewhere? Yeah. We still got plus 3 there, right? So these two would cancel. Does that take me also back to the original? So when you put that in there, good point. So when you put that in there, you can automatically cancel it out. Then look back at your function, put in what you need, and that's another way to think of it. Absolutely. You know what? Let me do this. I'm glad you brought this up. I'm going to jump into the harder one here first, guys. We'll try this. Hang on, hang on, hang on. This function, f of x. I'm getting carried away with this. X squared. Subtract 4x plus 2. Oh, I'm glad you brought it up. Here we go. Now, everyone in class, I guarantee you, every student in class, if I said solve that and take it up and score it, you're going to get it perfect. I guarantee you, every student in class right now, if I say solve it, find the zeros, you'll get it. Because I think most students will recognize first, will not factor. You probably use quadratic formula. I would use quadratic formula. But if I want to try this new method, completion of the square, which will be required in chapter 2, I got to play around with it. So guys, on this one, I'm going to be very, very careful. Let's rewrite this as x squared. Let's isolate the x's and show I need to do something to it to make it a nice perfect square first. That's the first thing I'm worried about. What's that square? And then a student told me, he said, to find what that number is, Professor, it's missing there, is take 1/2 of the previous coefficient, one in the middle, and square. Guys, 1/2 of a -4 is what? -2? True. And then square. So what's that missing number I need? 4. Then I'm hearing the student say, Professor, let's keep ourselves organized. You put a 4 in there. She said you could automatically cancel it out here, -4. Which you could. And did the original actually have a +2? Did I actually have a +2 up here? Which is still there. Now, is all this mess right here the same as the original? Is that the same as the original? Just playing with those numbers. And therefore now, this will now factor into, which I want, that's what they call a square, factor into a square. Now these two put together will be a -2. Now, can I solve it now? If I say solve it now, it says equal to 0, can I merely move that 2 over? If I say find the zeros, move the 2 over and do what to it? Take a square root, you get x minus 2 here, plus minus to ensure you get 2 answers because it's a quadratic. Square root 2, look at this. Add 2, you get the x by itself. Those are your zeros. And you did it through this method called completion of the square. It's a little different, to get the answer. Now, if I did, hang on now, if I said, no, Professor, I prefer a quadratic formula, let me redo it. I should get the same answers. If I don't get the same answers by quadratic formula, we've done something wrong here. Quadratic formulas would say the answer is x is equal to -4, -b, plus minus square root negative 4 squared, subtract 4 times, A is 1, C is 2. Now, this is my quadratic formula, make sure I put all my numbers incorrectly. 4 times A, looking nice. X is equal to positive 4 plus minus square root. Guys, underneath there, help me out, I think it's 16 subtract 8,
Yeah.
which is 8. This is my quadratic formula. So this is 4 plus minus, 8's not perfect, 2 root 2. I hope it is. Is it true? My quadratic formula. Now, will these numbers reduce down?
Yes.
By 2 into what? 2 plus minus radical 2. Same answer. Oh, my goodness. But before I take the questions here, you have not seen the tougher one yet, where the leading coefficient is not 1. Much same process. Process is much the same. I'll come back to that. Now you say, oh, Professor, I see sort of what you're doing. You're adding something, then subtracting it, and just trying to rewrite the function. That's all we're doing, rewriting the function. Yeah, go for it. Mama, what's that?
Oh, I'm just wondering if I had moved where are we? The positive 2 to the right side, so instead of setting it equal to 0, I moved it in the first place, so I don't have to do a plus 4 minus 4 on the left side of the equation. Would that ever give me an issue?
It would not, except you always have this much right here. You always have these two numbers. You mean you want to move that 2 over to begin with?
Yeah.
No, it should not.
Okay.
Should not. Okay. Guys, making sense? Now, I know what's going to happen. When I first saw completion of the square, I thought, what's going on? Then I thought, whoa, all that professor's trying to show me is that, believe it or not, this is equivalent to this. We're just rewriting. Those two are the same thing, I think, aren't they? And then solve it with that square. Guys, I know it's a little tougher. Okay, now we'll try this one. Guys, this one, where am I?
In the red, the bottom.
Did we solved it by, I think, factor. We have the answers. You said, Professor, got the answers, move on. I ain't gonna do it again. You know, sometimes you've got to show completion of the square, especially in chapter 2, for a reason when we get there. Guys, now I'm gonna redo it, get the same answers by completion of the square. The 2 had to be taken out to get that leading coefficient to be a 1, okay? Now, in the red, the x's is why I got the x's all by themselves there. Can anyone tell me, I better do this right here, in the red, what on earth, and I gotta be careful myself, is it gonna take to add there, and I'll immediately subtract it, and I'll keep mine, there's a minus 5 there also, to add there to make this thing come out to be a nice, perfect square. Mama,
Negative 9 over 16.
take 1/2 of this, take 1/2 of that coefficient, and guys, what's 1/2 of 3 halves, or 1/2 of negative 3 halves? You always take 1/2 of that previous coefficient, and that's merely what, negative 3 over 4, and then do what with it before you place it? Square it. Put a comma. That's what they call it, completion of the square, you gotta square this. Now, I think she told me 9 over 16, I think it was, that goes here. That's no problem. That's no problem. Now, what did I add there with that 1/2 business? 9 over 16. Now, you immediately must into what's that? Say, wait, Professor, that wasn't there to begin with. So subtract it. It's gone. But what else was in the original? Minus 5 is still there. Guys, you're talking about madness. Please tell me, is all this madness equivalent to this?
No.
If it is, I'm good. is this equivalent to this? These two will cancel. Don't have to worry about that. Multiply through by two, I got you, exactly, look at this. If you multiply by two, this is 2x squared, yes. This times this, the twos will cancel on the 3 halves, negative 3x. Got it. 2 times this, be careful. What's 2 times 9 over 16? What's 2 times 9 over 16? I'm just doing a little check here. Is that, do a little canceling here, is that 9 over 8?
Yes.
Yes or no? Is that true?
Yes.
Now someone tell me one little correction. I'm trying to see if they're equivalent. What's my one little correction to now be assured that those two functions are really saying the same thing? It's not minus 9 over 16, it's minus what? 9 over what? 8. 2 times that. It's 9 over 8, cancel the 9 over 8 out, now it cancels. And I still got my subtract 5 that's there to begin with. Madness. Do we accept that those two now are equivalent? They don't look equivalent. Am I good like a math students in Calc 1, Math 7? Is this equivalent to this? As a professor, no way. It is. This right here is saying the same thing as that mess down there. Now, let's make it look a little better. Let's write this down as 2. Guys, this should factor into a nice perfect square. What will that factor into if all this in the red is correct? Who has an idea? It should be a nice perfect square. Mona.
X minus 3/4.
Perfect. Has to be. That's done. She's done, the red's done. It factors. Perfect. Now, I got this on the end. I can somewhat put those two numbers together. This is arithmetic now. With a common denominator of 8. And what do we have for a number on the end if I combine those two?
Negative 49 over 8.
Love it. Love it. Now, in my little lesson today, you walk up to me on campus, I keep saying, now you walk up to me on campus, I'm asking you a math question. If you walk up to me and you ask me a math question, you say, Professor, I got a question. Oh my goodness, what is it? And I'm just walking on campus to class. You say, Professor, this right here is equivalent to this. It is. Now, does that look like it is? I wouldn't know myself until I sat down and did this. Who on earth would think that this is the same as this? And they are. They're equivalent. Now, why on earth would I want to put this in this form here? Because now I've already got the answers like factoring on this one. Much easier by factoring. I can now solve it in this form, and I should get the same answers. Guys, right now, if I were a student, I'd be shocked, even with all the math I had, that Professor, no way, that this, that looks so nice, and this one that looks so awkward with fractions, they're the same, Professor? They're the same. Leo, if they're the same, so when I solve this one, I should get the same answers as the other one, which we already solved, right? Now let's solve it. Guys, to solve this one, what would you suggest to do to solve this one? Of course, that equals 0, of course. Let me write this down. I'm getting scared myself. I am getting scared myself because with all those awkward fractions, you're saying, Professor, there's no way it's going to take you back to, where is it? These two answers. But you have like factoring way back from Algebra 1. Professor, I don't think it's going to take you there. It may not. Let's see. Okay, what would you attempt to do first to solve this?
Move negative 49 over 8.
Move that 49 over 8 over. Here we go. Move that 49 over 8 over. I would do the same. Then you might suggest divide by 2. Try to get the x. That, and by the way, guys, divide by 2 will take 1/2. I think we'll end up with 49 over 16 over there when you do it. When you take 1/2 on each side. Agree? Okay, then at this point, what would you do?
Square root.
Take the square root. Square root, I'm gonna bring it over here, guys. Square root of the left-hand side, no problem. That's x subtract 3/4. Plus, minus to ensure I get two answers. Now, the other side says square root 49 over 16, is that a perfect square root? And what is it? 7 over what? 4. Move the 3/4 over. You got 3/4 plus minus 7/4. Now, if you want to separate them, we'll go back to my black marker, will show up better. One answer, I'll separate them. One answer says 3/4 plus 7/4, which is 10 over 4, reduced down to what? 5 over 2. Where am I? Don't scare me. Oh. There it is. And then the other one, separated, is 3/4 minus 7/4. Guys, I think that's a negative 4 over 4, which is what? Negative 1. Oh. Now, before I take a question, I guarantee you, if I should ask the class right now, would you have preferred to have solved this quadratic by factoring like we did here and be finished with it, rather than redoing it by completion of the square and getting the same answers eventually? Wouldn't we prefer just to factor and move on? I would. So why am I doing this? Because sometimes they insist you show completion of the square, especially in chapter 2. You've got to show completion of the square, completion of the square. Guys, look at it closely. Theo, what was that question?
Just for the, right at the very end, if you do x equals 7 over 4 plus minus 3 over 4, does that mess up your, I mean, yes, but is
Hear
there
me right here.
the 3 over 4 before 7 over 4?
No, you're saying 7 over 4 plus 3 over 4 backwards.
Yes.
Same answer.
But then when you do 7 minus 3, you get a positive 1.
Oh, no, the order here is critical. Yeah, I see it up here though, if you mistakenly write the other way, you're okay. Yeah, if you write this one the other way, you're wrong.
Okay.
Yeah, you gotta watch the order there for sure.
So would you say it's smarter to?
I just stick with the order.
Okay.
If it's 3/4, keep 3/4 out front. It's like I did. Don't put the 7/4 out front. Guys, anything else? That sort of makes sense now? So when they say now complete the square from, in Math 7, you'll say, how am I gonna do this in Math 7, Professor? Everybody should complete the square. But you're not solving equations there. You're doing it for another reason. You'll see when you get there. Complete the square, complete the square, complete the square. Now, I'm gonna do this. I'm gonna quickly ask you. I'm not gonna solve this, guys. I'm gonna do this. I made that up real quick. I'd like to rewrite it. I'd like to rewrite it, actually have the same thing, but in a different form, and we'll do it by completion of the square. Now, here goes.
Third on the left.
Close it down. Isolate the x's. Now, can someone, this will look awkward as you know what, we're not gonna completely solve it. It's x squared subtract 9x. Anyone tell me what is missing? And thank goodness that leading coefficient is 1. I want you to do the division by 2 or take the 2 out. What is on that blank to make this work?
Negative 4.5 squared.
Go to it again. 1/2 of what? 1/2 of 9 or negative 9. And then squared. So what's missing? What do I need in other words? What is half of 9, which is 9 halves? And you square it. What is 9 over 2 squared?
81.
81 over 4. true? Is that 1/2 of 1/2 of 9, 9/2? And 9/2 squared, is that 81/4? And then what I would do, this will be a little bit easier, I'd quickly say, hold on, Professor, that was not in the original, so it's subtracted. But they still had what on the end? A +4 hanging on up there. Out here. Now guys, please tell me. Awkward, look at this. Is all this mess here saying the same thing as the black right above it?
Yes.
Yes. It's saying the same thing as the black above it. But now, what am I allowed to do though, since I did change its form a little bit by this completion of the square? Leo, I can now write this as, I think, x subtract, I need what here, 9/2, I think, squared. Is it true?
Yeah.
And then on the end, I got what, minus 81/4 plus 4, that would be arithmetic with a common denominator, what, 16? What is that, negative 81 plus, common denominator 4. A negative 81 plus 16, is that true? I'm trying to put those two together with a common denominator of 4. Guys, is it negative 81 plus 16? I think it is. What is negative 81 plus 16 on this Friday? What is it? Negative 81 plus 16 is a negative how much? Help me out. Negative 81 plus 16 would give me what's left?
65.
Is it 65 or 55?
65.
55?
65.
60?
65.
Wow, strange number here. So we got negative 65 over 4. Jeez. Maybe look at myself some strange numbers. Wow, wow, wow. There's no way, unless you know what you're doing, and I know what I'm doing, that you would ever think, Professor, no, it can't be. Are you telling me this up here, Professor, is black, and this craziness down here are saying the same thing? They are. There's the same function, just written differently. Now look how crazy this looks. Those are supposed to be the same. Aren't they? If we did it correctly. Now we'll leave this. I'm gonna actually do a little quick check on this one, since it does look so strange. Guys on the side here. I'm getting a little worried myself. On the side, let me clean this up. Let me clean this up, if all the math's correct. I think you guys help me out. What should that take me back to if we are correct? After I cleaned up, what should it come out to be if we are correct?
Your original function.
It should be the original, x squared minus 9x what? Plus 4. Okay, here we go. I'm gonna expand the orange. Can anyone tell me the orange there? Expand that out. What on earth is that? I notice it's gonna be an x squared. Can anyone tell me what it looks like without me actually setting it down and doing it for you? And I'm looking at myself there. What do you think? X minus 9/2 times x minus 9/2. Someone tell me what do you think it is? X minus 9/2 times x minus 9/2. What is it?
Negative 81.
Help me out. Been bragging on you guys already.
What would be
X minus 9/2 times x minus 9/2. Boy,
minus 9?
x squared, I got the x squared minus 9x. Minus 9x in the middle. And what's on the end?
Minus 80.
Not minus, the plus, because
Plus
it's squared.
81/4.
81/4.
And then plus 4.
Then you got what? Minus 65/4 in the green. Oh boy. I just hope we didn't mess up there. Guys, please tell me. We expanded the orange, and you can do that by FOIL. And my students tell me you get something like that. You expand it out. And now I had a minus 65/4 in green. Put all that together. I got this, yes, that checks. What scares me is, will that give me that.
Yes,
That's
it'll
it.
give you 16
Thank
point
you.
four.
They are equivalent. They are equivalent. I'm checking my time here. Class started at what time? Around 12:30? What time is it right now? Almost 1:30?
122.
Took me that much time just for one concept, completion of the square. I hope, I planned this last night, I've done this so differently in different classes. I'm hoping by the way I did it with you guys, I hope you understand now what's going on here. It's gonna take a little practice to go from one function to another function to make sure they are the same goal, but they're just written differently. Did that help, guys? Completion of the square, that's all it's known as. Okay, now on the exam on Monday, you're saying, Professor, you want us to do an equation by completion of the square? You don't have the handout. Did I get the handout to you? What's problem number one asking?
By completing the square.
Complete the square, use completion of the square. And I've had some students do this, they'll sneak and try to do it by quadratic formula and sneak in the answer. Like if I'm not gonna look at your work. Yeah, they'll sneak around and do it by quadratic formula. And all of a sudden, you get back to your paper and got a 0 on that part. I said, do it by completion of the square. Okay, so we have to know how to do this completion of the square. And by the way, I think I went through a lengthy process on the back, flip it over there. Did I go through a real lengthy process to show you how that works again?
Yeah.
Complete, yeah, so you look at that little lengthy process to help you see how to get that. Yes?
I have two questions. One, I just wanna make sure when you have a coefficient in front, like in the,
That's the hard
one
part.
with the 2x.
That's the hard one.
You always divide what you add on the outside by.
And you want,
the
you do this,
coefficient
and
you
do,
have.
got you. Eric, right?
Yeah.
Eric, just help the class out. Jonathan, since you're up front, tell me what the equation was on that review
Yeah.
that we were trying to complete the square. I'm not gonna do the whole thing, we'll just set it up.
So, 2x squared minus 3x minus 1 equals 0. Yeah.
Okay. It's much like this one right here. Right? 2 there, could be a 3, could be a 4, but it's a 2 again. Now, what should I do first here? If that leading coefficient is not a 1, you gotta take it out. Or was it equal to 0? You could actually divide by 2, get rid of it altogether. And rewrite it as. Eric, I'm glad you asked. You can do that first, since this is equal to 0, divide both sides by 2. Is it true? Now, is my leading coefficient now 1
Yes.
on the x? So we'll group that. Watch carefully. Just keep my numbers straight here. So I got x squared, subtract 3/2 x. Now tell me inside there,
9/16.
look at that. What will I need to complete the square? Take 1/2 of 3/2, that's what, 3/4, there's that 9/16 again coming in on this one. So 9/16. Now what you could do is quickly, and be careful, oh, by the way, was there a 2 out front? Oh, on this one we may have lucked out. Did I actually get rid of the 2 altogether when I divide both sides by 2? Which it might be even better if it's already set equal to 0. And will now that give me, I'm gonna subtract 9/16 and then bring that minus 1/2 back in. Oh, I see what he's asking about. Do I ever have some clever students?
Oh, but now since we've divided by 2,
Yeah, now tell me, is that equivalent?
yes.
The way he gave it to me? With these 2 will cancel. Minus 1/2 is that what I originally had here. And then I can write this quickly as x subtract what, 3/4, I think it was, squared. And put these 2 together. Okay, see if I got everything together here, guys. Oh, in fact, no, it's just minus 1/2. Is that true?
Yeah.
Equal to 0. These 2 cancel. And then I can solve it from there. Move the 1/2 over, be a little awkward, but you can do it. Does that make sense? Eric?
That actually leads nicely into the second question I had, is when you have these fractions that don't really, root nicely, like 49 over whatever we had rooted really nicely, but 65/4, when you root that, that's not.
That's not nice, but you're gonna have to leave it square root 65 over 2, I guess, if you give me a 4.
Right.
You just gotta leave it.
But you leave the 65 over 4, or over 2 inside the square root?
Yeah. Well, if you take 1/2 of the previous coefficient and square it, so on that, on the end there should be no square root because you're squaring it.
So wouldn't it make it kind of a mess to solve?
It's gonna be a mess. Now, am I gonna give you one that messy? No.
That one's kind of that messy with the one.
Well, this one was, which one are you talking about? This one
The
right
one we
here?
were just doing with the 1 over 2.
Oh, this one right here.
You square that, that 2 on the bottom doesn't square out nicely.
Oh, I got you, hang on. You're saying if I now should finish it up.
Yeah.
Here we go. We'll finish it up, mathematicians. You do this, and we move 1/2 over, if you actually want to just solve it. And then do what? A square root on each side. I know what he's after. Asking. Left-hand side, no problem. Plus, minus. Now, what's the problem?
You can't
Square root 1/2, but what you do there is remedy this. That's the same as taking square root 1 over square root 2. This. Which now can be written as plus minus 1 over radical 2. And what we discussed just the other day about a radical in the denominator. You can't leave it. Because rationalize it. What would you do now to get rid of it if they do not want it down there? How can I get rid of that radical 2?
multiply by.
Multiply by radical 2, called rationalizing. And you will end up with plus minus radical 2 over what? 2. Which looks better. That's your right hand side. You would still have on the left, in the green, you still have this. With that. And you have to move the 3/4 over, combined with the common denominator. Eric, since you asked, let me move the 3/4 over. Plus minus radical 2 over 2. Now, guys, what would that look like now if those two put together, at least with a common denominator of 4?
2 radical 2.
Wow, hang on, not 2. With 3 plus minus what? 2 radical 2 all over what?
All over 4.
4. If you combine at the end with a common denominator. Wow, what questions I have received today. It took a chunk of my time, but I'm glad we got it out of the way. Jeez. Eric.
Yeah.
Class. If you follow all this, I know there's a lot of little pieces to follow. If you follow this, let me go back real quickly. Redo this. We start here. This is what he's talking about. Let me redo it and do it by quadratic formula. Rather than this. Okay, if I do it by quadratic formula, am I going to end up with, I'll do it quickly guys, 3 plus minus square root, I'll say a 9, subtract 4 times a, which is 2, negative 1. Oh, wait, is that the same problem? That's not the same problem, is it? Which problem did I just do? I've done so many up here.
The 2x squared minus 3x minus 1 is equal to 0.
That's the one we did with the 2 there.
That's the
Okay.
one we just finished solving.
Can we finish that up? Okay, hang on.
In the green on the right.
Okay, hang on.
Yeah, no, you're right.
It's a 3 here, right?
Yeah, it's negative 4 times a times c.
And the minus b squared minus 4 times a,
Wouldn't it be 2 times negative 1?
now I lost me here. 3 squared, geez, 3 squared is 9, right? B squared 9 minus 4 times a times c, that's a 2, right? Did we have that correct at first?
Yeah.
I think. But I am checking something here, it's not working out for me. 9 minus 4 times a times c all over, I'm gonna end up with a 17. And what on earth did we do here? I think I did a different function, I think. How did we mess up here? Eric, you were asked about this. So I
Yeah.
picked up with where you were, Oh, boy.
So A is two, B is -3, and then C is -1. So it should, yeah, +3.
B squared minus 4 times A times C, I put those in correctly, didn't I? And that's a square root 17. Is it? Up there?
Yeah, it is. -4 plus -2 times -4 should be 8. So
Yeah, right, so what's the 9, I see a plus.
Yeah, 9 plus the 8.
Plus 8, that's 17?
Yeah,
Okay,
so square root.
right, I'm gonna get a square root 17, yes.
I think you messed, well, you did it differently on here. You moved the 1/2 to the 0 on the completion of squares.
Let's see, where am I? You moved the 1/2, where am I now?
Instead of canceling out 9/16.
Oh, right here.
Yeah.
I moved the 1/2 over. That's what guys, on the other side there, on the handout. And did that, and then complete the square. That's what it was there.
Yeah, you did.
But his big question was, same process though, is Professor, if I should end up with something strange like this, I don't know whether I did it on the handout or not, can I still deal with it? You can if you rationalize. You can. Yes.
Going back to the solution in the green, where did that leading to come from next to the square root? So-
You mean where, right?
So the solution is 3 plus minus 2 radical 2, where did that,
On the right side, right there, right corner.
3/4.
Oh, right
the
here?
solution?
Oh, over here.
Bottom.
Yeah, down.
Okay, I think I moved that 3/4 over, and then I combined with a common denominator of 4, so I multiply this one by 2. So that we'd have a common denominator. Now that everything's over 4. But that shouldn't happen. Geez, let's not confuse yourselves, guys. So look at it, practice with it, with this strange completion of the square. Now, I know it's strange, took all my time here almost, just go through that. Yes?
Why did we cancel the 9/16?
Ah, beautiful, beautiful. That's what she's telling me. She's saying, wait, Professor, what you did on the handout to keep everything straight was, well, just give it to me here, let me do this. Let's get that straightened out right now. Let me do it right here. You guys are saying, the original was 2x squared, remind me guys, 2x squared. What else?
-3x. -1.
Equal to,
0.
and we said equal to 0. Okay. So it didn't say find the real zeros, it actually already said equal to 0. I think on the handout, what I did was to isolate the x's and move that 1 over. I think that's what a student told me I was doing on the handout. Are the x's isolated? That's another way to think of it. Now, the leading coefficient is gonna be a 1. So divide everything by 2, you're going to end up with this. At this point. Everyone agree? Then what you could do is say, I've got to complete the square, the leading coefficient is the 1. So Professor, do all that please on one side where the x's are, don't confuse anything. In other words, now you're going to do this, it looks nice. And whatever that is, you got to add the same thing to the other side, keep things balanced. Is that making sense? This is another way to approach it. I think it's the way I approached it on the handout. Guys, on the blank there, it's gonna take 1/2 of 3/4, 3/2, I think we did it. 3/4 squared is what? 9 over, you got that number again. That number again. I think that's what he's asking. Hang on, let me finish it up, right. Now, this should be a nice perfect square. We saw that earlier. True? Now if I put those two together, there's a little process here, with a common denominator of 16, I have to multiply this one by 8. 8 plus 9, is that 17? That's where that 17 came in. And then do a square root on each side. And if I do a square root to actually find the answers, much easier this way. You're going to end up with x subtract 3/4 is equal to plus minus, now it's awkward over there, so it's radical 17/4. Then move the 3/4 over, mathematics. Please tell me, without me doing too much more of my time here, will this eventually lead me back into where we were going up here on that check? Did we have a 17 underneath there? It would eventually lead me to the same answer. I think that was your concern.
I think, I was gonna say, I think, when we did the problem last time, we accidentally actually subtracted the 9/6.
We did, that's because I didn't quite understand what that problem was when it was read to me at first. But now, yeah, we got this settled now, guys. So check on the back there and see what I did. I try to keep it organized for you on the back to make more sense to you. So look at it, see what's happening here. Guys, don't let this completion of the square throw you. I'm gonna be doing it again in chapter 2, a little bit easier by the time we get there. That's awkward, it is awkward. As you know what? Except when the leading coefficient is a 1, it's beautiful to rewrite. But when that leading coefficient is a 3 or a 2 or a 4 or whatever, it's awkward. Yes?
What happened in the first run? Like, what wrong happened to get?
Yeah, because I did not, that's why I was asking. They did not list this, if they say find the real zeros, and they say f of x equal to, rather than saying x squared minus 4x plus 2 equal to 0 to begin with,
Oh.
that may throw you. That's what was throwing us up here.
So it would be better in this case if it's equal to 0.
If it's equal to
isolate
0,
the x and
like this
y.
one on the handout, beautiful. Okay, set equal to 0 is much easier, I think, like I did on the handout. So guys, stick with the handout. Thank you so much for your suggestion there. I see now what I did. Guys, anything else?
If it's given to you as f of x, you cannot set it.
Yeah, that f of x, I did some of those earlier. That's where you have to put the number in, then subtract it, make them cancel out, then do something else and make sure everything's equivalent. Yes. Okay. Guys, anything else? Whew, that's enough. Oh boy, is it enough. Now, you know me, real quickly. Eric? Class. I'm not going to do much here for this. Oh boy, do I want to? I don't know what, they don't pay me enough to do all this. Here we go. I'm not gonna solve it. I would just like to put it or complete the square on it. In other words, rewrite it. Just rewrite it. By completion of the square, what would be the first step?
Factor out 3.
Take out the 3 on the axis. And awkward, the 1/3. Now, if you practice a little bit with this, it's not hard. Everyone agree so far? I take out 3. Now, I gotta complete the square inside there. Yeah, see, I'm hearing it already. And what would that be? It would be 1/2 of 1/3, that's 1/6.
Within square.
Squared. What is that?
1/36.
1/36. Now this is a type where, yes, you quickly, since it's a function, subtract it to show it wasn't really there. And you still got +4 though on the end. Now please tell me guys, are though, no, I gotta be careful myself. Let's check it. Was that 1/36 being multiplied by 3 that I put there?
Divide the
Is that 1/12?
by 3.
Is that a 1/12 there, guys?
Yeah.
Let's subtract 1/12, not 1/36. Now, let's see if those two are equivalent. We'll just check them, I'm gonna solve it. It looks like this. Can't do this until I do this. And then you put those two together. With a common denominator of 12, I'll do it quickly. I think it's 47/12. Awkward number, but we're good. Is that true, guys? Now, I will tell you in closing, geez, I'm closing this down. There's no way me, I don't think any professor ever, even Einstein, you look at this, and you look at this, are you kidding? Which one would I prefer to work with? That. Now, is this equivalent? and then I'm gonna stop. If I did my work so quick on this one, I'm gonna check it. If it's not equivalent, I'm gonna say, guys, that's enough. I think I've done enough. I'm gonna check it. Leo, you wanna help me out? I'm gonna multiply this out, or clean it up. Strange looking numbers over here. And it better take me back to this. I did this one quick. Here goes. 3 out front. If you expand this, x subtract 1/6 times x subtract 1/6, you're gonna end up with x squared minus 2/6 or 1/3 plus 1/36. That's this by FOIL, you guys call it FOIL, x subtract 1/6 times x subtract 1/6, you can check that out later. About 3 out front, and still about 47/12 down here. I'm just checking my work. Distribute property, multiply through by 3, you're going to end up with, here it goes, 3x squared minus x plus 1/12 when you reach the 1/36, 3 into 36. And I still got 47/12. I got 3x squared, subtract x. Please tell me, what will those two put together be?
48/12.
48/12, which is? 4. Please tell me, is that what the original function was? That's what it's all about. So you walk up to me and ask me, are those two equivalent, which is on campus? I have no idea. I would have no idea. Who on earth would think? I wouldn't. Nobody would. Professor, this is equivalent to this. Well, I prefer this. I don't want those fractions, but they're saying the same thing. Now, why I do this? Chapter 2 is going to show you really a big reason why you got to do it. You've got to change it for a big reason. That's why I'm doing it now. Yes?
Why do we, when you first do like the halves and then the square, why do we change the 136 outside of parentheses to 112?
Oh, beautiful, beautiful. Why? Because that leading coefficient says it's 3 times 1/36. That's 3 there, so when you distribute the 3 on the 1/36, you get 1/12. 3 into 36 gives me a 12. That's why it's a minus 1/12, not a minus 1/36. If this leading coefficient had been a 1, which it wasn't, then it would have been just minus 1/36. At 3, you got to be careful. At 3, it's having an effect on it. So we have made it 1/12. Making sense, guys? Yeah, what a chunk of my time here being used here. How do you do it though? Guys, that done, my goodness, I should say, completion of the square should be done. I wrote myself a note here. What did I say here? Do it. Yeah, we're doing it right now. I gave you a handout yesterday. This will take me right to the break. There was a section there I didn't touch yet. Please find that, I think it's on that long paper. Piecewise defined functions, I don't think I've done anything with that yet. Okay, I did. Look at all this board space on completion square. Guys, before our race begins, before our race, no one would think that well-behaved, nice-looking quadratic with nice numbers, so easily done by quadratic formula, that it is the same as this crazy thing with these crazy fractions. They are the same. And you will see, like I said in chapter 2, why we have to change something that looks nice into something awkward with some fractions there. But first, let me jump into where I should be. All that said, like I said, this is gonna be right through the break. Get it out of the way. Now, by the way, you guys, when you leave us, if you ever have to have another math course, and you go to Stanford, Berkeley, we have students at all these schools. In fact, Mr. Parker, where's Mr. Parker? We were just talking about the kid at Columbia, right? I had him in math too. He's doing math. I think he's going to do math there, you said?
Yeah, he's gonna take Calc 2.
Yeah, he's going to take Calc 2 at Columbia. I'm proud of him. But I guarantee you one thing, you're not gonna see all the examples I showed here. If they're discussing completion of the square, they will use the words completion of the square, show you one example, and they're gone. They expect you to do the rest of it. So guys, make sure you understand what's going on here though with me. Okay, part one, here we go. Yes, functions. There's a special set of functions known as these. Piecewise defined functions. There's a professor out there that can do an f of x. What do you mean now? Well, they're gonna give you an f of x, but they're gonna give you in pieces to work with. Now, Jonathan, before I ask you, let me try one here myself. Look at this, guys. F of x is equal to, here goes. Rather than saying f of x is equal to x squared minus 2x plus 4, like I've been doing, no. They're going to now give you pieces. My first one I want to look at is two pieces with some restrictions. Like that. I could have 3 pieces, 4 pieces, 5 pieces. I'm going to start out with 2 pieces. And then they're going to ask you to graph it. Graph that 2-piece function. Now, I don't know, some of my students are coming into this class with some experience. Does anyone think they know when I finally plot and graph this? I see some heads nodding already. They're saying, Professor, I think I know what the shape's gonna look like right now. If I were a beginning student, I'd say, what on earth's going on? What is he asking me to do? He's asking me to graph this, Eric, hang on. Now, if we are patient, not doing the math too quickly, we go to a grid. Here we go. I'm patient. Got the x-axis, the y-axis, no problem. I would suggest, and we use different colors, deal with each piece, and we use green for the first piece. Now the first piece says f of x is equal to x, that's y is equal to x. Restriction, the x must be greater than or equal to 0. I don't mind if you, way back from algebra, if you form a table on the side there to satisfy, it says you may use in the first piece any x that's greater than or equal to 0. So we'll start out with 0, they give it to me. And all further saying you may use, to see what's going on here, anything greater than 0. We'll try 1, 2, and you try others if you wish. That's what they're saying. The x can be greater than or equal to 0. Now what's the y? Well, you go back and plug that in. Here's your function. Not much going on here, because if you go back to that first piece and plug in 0, you get 0. And that is an ordered pair. If you take the 1, put it back into my function, which is x, you get 1. This is not exciting. 2, you get a 2. 3, you get a 3. 4, you get a 4. So see what's happening on that first piece. With those 3 points that I plotted, I'm going to go up to the side here and plot them, or that created a table. I will now plot them. 0, 0, I am going to include it. Because I see the equals mark on this one. Then we have out 1, up 1 can be used, and out 2, up 2 can be used. Those out of the way right here. Guys, out 1, up 1, here. Out 2, up 2, here. If you went back to your table and tried more points, you can try more points. If I connect what I have, that first piece that I have in green is gonna look something like this. That's my first piece done. It's done, I applied points. Now we'll jump down to the second piece. The second piece, I'm gonna try it in this orange looking color here. If it'll work for me. Now it says try something less than 0. Well, we'll try 0 itself first, because they gave 0 as a reference. But anything less than 0, let's try maybe -1, -2. And I can try more if I wish. Now, we'll take them back, replace them in my second piece of the function, which is -x. Replace x by 0, get -0. Not exciting. Put a -1 back here in my second piece, negative a -1, turns into a 1. Put a -2 in, negative a -2, when I do my replacement, gives me a 2. Now you can try more if you wish. Now plot those. 0, 0, just so happens lands right here where the green left off. So that's where my next piece is gonna start. And it says also out -1 up 1 can be used here on the second piece. And -2 up 2 can be used. Guys, on the orange, I can do this. -2 up 2 here. Knowing that 0, 0 is also there. Connect these. And my second piece is gonna look something like that. There's my piecewise function, the graph of it done. Now, yesterday, did I not point out some parent functions?
Yep.
Like a parabola, and I forgot what else I pointed out that could be considered parent functions. Does anyone recognize the graph of this?
Absolutely.
That's the absolute value function, except they gave it to me in pieces this time. So this is equivalent to, look at this, who would think this? This is equivalent to this. Except they gave it in pieces this time. Now, got 5 minutes. Done. Would you read from the handout? Is the first example in the handout, does it have 3 pieces?
Yeah.
Now, you walk in here on Monday, I'm not gonna do this to you. But can you imagine if it were 6 pieces? 4 pieces? 8 pieces? It could go for a long time. I usually keep it to 3 pieces. Okay, so name that function for me.
So f of x equals, the first piece is 2x plus 5.
Now wait, hang on a second. 2x plus 5, I'm gonna do it in black. If what?
If -3 is less than or equal to x, which is less than 0.
Now, I'll do that in black when I get to it. Now tell me the next one.
-3
-3,
if x equals 0.
got it. I'll do that in green when I get to it. How about the third piece?
X squared plus 1
Yeah.
if x is greater than 0.
And then with the graph. What the graph may look like. Here we go. Guys, by the way, I've got some accelerated students in this class, quite a few. Does anyone think they know what 2x plus 5 is going to graph into, even before I start plotting points? It's going to be a straight line. It's in the form of x plus b. But, since I'm going to do it, let's try points. I think this helps. Now, what am I allowed to use? Well, they gave it to me. I start with a -3 and go to a 0. You may try points like that. So everything comes between -3 and 0. Guys, we'll try a few. Try this, and then we'll just jump to 0. We'll try 3 points. All those are caught between -3 and 0. You can try others. I will take them back and put them into the black function and see what the value is. I'll take a -3 that I chose, back, -6 plus 5 is -1. Plot that point here, shortly. -2, what was that? negative 4 plus 5 is a positive 1. Don't want to make a mistake here. And 0 gives me a 5. Is that true? Okay, let me go ahead and plot those right now on a grid and get the black piece out of the way and see what's going to happen here. I'm going to take a break. And we got all this going on. So I've got negative 3, negative 1, so we go out here and mark my grid so I'll know where I am. And negative 1 down here. I go up to 1, 2, 3, 4. I'll squeeze that in, 5 up there. Just try to get that grid ready for it. Okay, first, negative 3 down 1. If I've done it correctly, I'm doing it in black here. Guys, that point's going to start here. Please tell me, should I have it closed in or open?
Close.
Closed because I see the equals mark. I got negative 2 up 1. The other points are definitely going to be closed. Negative 2 up 1's right in here. And then I got 0 up 5. Now, when I finally reach 5, what happens? It's happening. 5's on the end where I use 0. Was there an equals mark at 0?
No equal.
No, so at 5 should be open. I plot the points correctly. I'm on top of the board there. Are they plotted correctly? And the last one's open, connect those, and we have on mine, line up something like this, if I can make it line up. Something like that. And there's my first piece done. Is that making sense, the way we're approaching it? The next one says, oh, thinking the ring was easier. No table needed. It merely says when x is 0, the y is what? Negative 3. That's all the ring says. No table needed. So plot that. That says merely drop down to a negative 3. 0, negative 3 is down here. And guys, that's going to be a point all by itself. The green right there. That's piece number 2 done. Piece number 3 in the orange, to it, it says you may try anything greater than 0. So I'm going to try a few values here. We'll start with 0 since they gave 0 as a reference. We'll try 1 and 2 and hope that's enough. If not, I'll go back and try more. Take 0 back. 0 squared plus 1 gives me a 1. I'll use it. Put a 1 into my orange function. I'll get a 2. Put a 2 in, we end up with a 5. By the way, does anyone know what that orange function should be a piece of? A parabola. It's a quadratic. Okay, now let's see what the piece looks like. Going in orange. Now, it first says 0 up 1. Guys, can I include it? Here's 0. The way it's written. Did I see an equals mark here? No, so 0 up 1 is going to be open. The others, out 1 up 2, and out 2 up 5. We'll get that on here. Let me get this out of the way here. Out 1 up 2, right in here. And then out 2 up 5 is up here.